All right, welcome to our last lesson in Unit 2B module. So we're looking at solving absolute value inequalities, and this is the last piece on the compound inequality concept we've been working with. So we looked at compound inequalities as in problems that can solve with more than one answer or more than one solution, and absolute value inequalities by nature are very similar to that. So our goals are today is that you'll be able to solve, graph, and write the interval notation for absolute value inequality that does not overlap, so an or inequality, and do the same thing for another and inequality. So those are your basic goals today, and it's really going to build upon what you learned in Lesson 10. So be sure if you're stuck or have any questions on Lesson 10, make sure you reach out to the instructor beforehand so that you can fill in the holes so you'll be able to jump into this lesson and not have any questions or concerns. So let me start here with this idea. So we've already kind of worked this through. So if this was an x is equal to 5, the absolute value of x was equal to 5. And that's kind of where I'm going to start today, is make a couple connections here. So what we would have done is gone, okay, x is equal to -5 and x is equal to 5, right? That's how we would have solved it if it was an equation. So what we're going to do now is very similar to the same thing. We're going to follow those same ideas. So we're going to switch the second sign and work it through. So to do that, so the first one stayed the same. So x is greater than or equal to 5. And then the second one would be the same idea, but we're going to have to take the switch. So just like here, we switched it to negative. So if that's -5, in essence, we're going to multiply the everything by -1. So when I multiply or divide by a negative, I've got to remember to flip my sign. So these are really what I'm going to graph. X is greater than 5, so here's 5. Fill in our circle. And x is less than -5. So these are our signs. There's one type that we're going to look at today, and these are absolute value inequalities. Let's take a look at another one, and then we'll kind of come back and look at them. So the biggest difference here is the only thing I did is I changed the base sign. So before was greater than, this is less than. So I would do the same thing again. X is less than or equal to 8. So I'll graph that less than or equal to 8. So, okay, so that's going to go this direction. Then we're going to do the same thing. And -8. So greater than -8. So we're going to come over here and go, okay. So really it turns into an and inequality. Okay. The previous was or, this is and. So what we're going to learn here is that absolute value inequalities are just inequalities that are really just another way to look at a compound inequality. So we just have to be able to realize which type they are, okay? And if you kind of remember back from my example, you'll see that if we look at that, less than inequalities were ands, okay? So anytime you start with a less than inequality, once it's isolated, you're going to have an and inequality, and that means anytime after you've isolated the phrase, just like you would have with a greater than, you're going to have an or inequality. And so that's what we're going to take a look at as we go through today. So I've got quite a few lessons, if you'll notice at the very bottom. There are actually about 10 more slides, so we've got 10 practice problems on this. So this is our goal to kind of keep in mind. You can shorten this if you want. We're going to use this 4 steps to kind of work our way through it. So, and this was step number 1. If you remember solving absolute value equations, was to isolate the inequality. So get it down to where whatever is inside the absolute value, whether it's x minus 4 or 2x, 2x minus 3, that everything, the only thing that's left on that side of the equation is going to be, okay, inside the absolute value notation. And that's what isolate means. And then we're going to create the 2 cases, and that's what we were doing a minute ago. So we're going to follow the keep it switch. So one is going to stay completely the same. So like our example, like x is greater than or equal to 5. One of them stayed as x is greater than or equal to 5. And then we use the KISS method, the keep it switch. So I keep the first x, switch the sign, and switch the value to its inverse. And then if there's more to it, we'll solve the inequality. So if it was something like this one, we'd solve the inequality here. And then we graph the answer. Okay, and that's what we're going to walk through today. So let's kind of work our way through it. So looking at this one right now, that's a less than sign. So it's already isolated. So that's my first step. So now I'm going to switch it. And I find it really easy to kind of go from here and going, okay, rewrite these equations. x is less than 7. And now I'm going to keep it, switch, switch. And that's where this comes in. Now I'm going to solve it. So x is less than 7, so there's 7 right there. And x is greater than -7, which is right here. So since I had a less than inequality, it was the same as and. Okay. And that's my information. Now, if you remember right from this, that means we're going to write our interval notation as, okay, where does it start? It starts at -7, open circle, so that's a parentheses, and it stops at +7, another open circle, so another parentheses. There's my interval notation. So let's take a look at another kind though. This is obviously starting now with a greater than. I don't have the steps over here this time, so let's work it through. It's isolated. There's nothing outside of these absolute value notations. So we're going to split out the equation, being okay, x, keep everything the same on the first one. And then we're going to do everything switch to the next one. X, switch, switch. So x is greater than 4 or equal to 4, so that puts us here. And x is less than or equal to -4, which puts us all the way back here. So for the interval notation, again, we read left to right. I'm just going to kind of read like that. So we're starting out with that arrow. Arrow was in the order further away to say infinity. And that first set stops at -4, so we're going to go to -4. It's a closed circle, so we use brackets. Okay. And then we come over here and go, okay, it starts again at 4 and then goes on forever. And that's our interval notation. So let's take a look at one that has a couple more steps involved. So is it isolated? Yes. So this is the only thing. There's nothing outside. There's nothing out here. So it means there's nothing to isolate. It's okay to have that one over there. So now we're going to create those two different cases. X minus 1 is greater than 6, and x minus 1, let's write myself neatly, is less than -6. And that's what the two different cases look like. Now we'll solve the inequality. It's the first time we've actually done all 4 steps. So we'll add 1 to both sides. So this one's x is greater than 7. Now we'll come over here and do the same thing. Add 1. This time we get x is less than -5. So we're going to graph these signs. So x is greater than 7. That's right here. Less than -5. So less than, greater than. Interval notation writes as -infinity all the way up to a -5, both parentheses, or 7 all the way on to infinity. That's my interval notation to work through. Okay, so let's keep looking as we go on this. Let's take it one step further. It's different type of signs. This time I'm going to ask you guys to identify the interval notation at the very end after we solve this. After I solve this, then you're going to kind of graph it on your own on your paper and then identify the interval notation through a multiple choice question. Okay. So the first thing we'll do is it isolated? Check. Okay, so now we're going to use keep it switch switch. So x minus 2 less than or equal to 7, and x minus 2 is greater than or equal to -7. Solve. So I get over here x is greater than or equal to -5, and over here we get x is less than or equal to a 9. So now that I've got this, those are my two numbers. I want you to take a second, pause the video, and graph it, and then write the interval notation, and then answer the multiple choice question. All right, so let's take a look at it. So if x is less than 9, so 9 is kind of right here, so we'll just put a dot up there. And greater than or equal to -5, that puts it right here. So I've got right here, so I get from -5 to 9, both in brackets, and we're all set. Good job on that one. All right, so now I've got a little more complicated portion inside the variable. We have both a coefficient and a constant. So let's just solve this one together and kind of see how it works. But you kind of should be starting to build that repertoire of what you're able to do at this point. So is it isolated? Check. All right, so create the two cases. 2x plus 5 is greater than or equal to 3, and now we've got 2x plus 5 is less than or equal to negative 3. So we'll solve both. We'll subtract 5. So that's letting me 2x is greater than or equal to a negative 2. And over here, 2x is less than or equal to a negative 8. Divide everything by 2, leaving me here as x is greater than or equal to negative 1. And over here, giving me x is less than or equal to negative 4. So now I've got my signs. It's greater than negative 1, so I'll go ahead and do this one. So here's negative 1 equal to, it's going to go greater, less than 4, negative 4. So it's going to come out here. So we've got negative infinity all the way up to a negative 4, or negative 1 all the way on to infinity. And remember, that just means the only answers that cannot be correct are between negative 4 and negative 1. All right, so now here we've got something that's not isolated. So here's that next idea. The first step, this is the first time we're doing these 4 steps. So this is the first time we're actually going to have to solve this step. And so one of the things you're going to get in mind as we keep going through this, you'll see that it gets more and more complicated on the isolation portion. And that's what we've kind of got to work on. So let's start over here. This is the part we want to keep, okay? So in essence, if you're thinking of isolating, if you think like an x minus 1, really this is the one thing you want to stay over here. And the other one you want to move is that's just this negative 1. So we're going to add 1 to both sides. That leaves us with x plus 3 is less than 6. And that's kind of where we're at. This creates that isolated step. There's nothing outside the absolute value notations at all. Okay? So now we switch the 2 cases. X plus 3 and 6. And then x plus 3 is greater than negative 6. Then we solve, we subtract 3. So now I'm getting over here, I'm getting a x is less than a positive 3, and over here we're getting x is greater than a negative 9. So greater than negative 9, less than a positive 3. We're going to get our numbers here of negative 9, comma 3. And since they're open circles, there's our final piece. So our first taste of working with the isolation steps. So now, this is the part that starts to mess with people. This is the biggest mistake I'll typically see, is people want to distribute. And the answer is don't. Okay? Don't distribute. Divide. Treat it separately. Okay? Remember the true property says I can distribute and get the same answers if I don't distribute. So, and it doesn't matter either way. So we're going to solve our problem. We're going to save some time. So the first thing we're really going to do whenever we have a multiply or divide, we're going to divide it off or multiply it off on both sides. This creates that isolated absolute value location. Okay? So this is what I want. This is that piece I need to do the problem. Don't, repeat, I want to say it one more time, don't distribute. With absolute value inequalities, we don't want to do it. So we're going to go ahead and set those 2 cases. I'll set them up on opposite sides. So 2x plus 8 is greater than 10, equal to, and now we have 2x plus 8 is less than or equal to a negative 10. So we'll solve this first one. We'll subtract 8. 2x is greater than or equal to 2. Divide by 2, x is greater than or equal to 1. And over here, we'll do the same thing. We'll subtract 8. So 2x is less than or equal to negative 18. Divide by 2, x is greater than or equal to negative 9. So we'll graph this. So x is greater than 1 is right here, and x is less than negative 9 is right here. Fill in both my circles. And we've got our graph. All right, go ahead and choose the correct interval notation from the multiple choice question. All right, so you guys can see that it was negative infinity to negative 9, and then we jump over here to 1 all the way on to infinity. All right, so let's add to a little bit more of what's on the outside. So now we've got a division step. So again, the goal is to keep just this right here on this side. So If I get rid of this division, how do I get rid of division? I use multiplication. So I'm going to multiply by -2. So here's the thing that's going to catch you on this. What do I have to do with this sign? I multiply or divide by a negative with an inequality. I take the opposite of everything. So this becomes 4x minus 8 is now greater than or equal to a positive 12. We have to flip our sign because we multiplied by a negative. So now we create our two cases. 4x minus 8 is greater than or equal to 12. And over here we have 4x minus 8 is less than or equal to a negative 12. All right, so let's work this one real quick. So we add 8 to both sides. So 4x is greater than 20. And now we have 4x is less than or equal to negative 4. Divide both by 4, so we get x is less than or equal to negative 1. And we get x is greater than or equal to 5. So x is greater than 5 puts us right here. X is less than negative 1 puts us right here. Got to fill in both these circles. And then we get our interval notation of negative infinity all the way to negative 1, or 5 all the way on to infinity. So we have parentheses and brackets around the numbers. All right, that kind of gets us all through the steps. So I want you guys to go ahead and give this one a try. It's got both pieces. Remember, constant first, then coefficient, and then solve. Okay, pause the video, and you'll have 3 different pieces for this. Actually, just have one answer. You're going to have just the interval notation on this one, and you can check that. Once you get it all solved out, you'll be able to figure it out. All right. All right, so let's go ahead and do this. So we're going to add 3 over here. So we get 10 times x minus 4 is greater than 50. So now we're going to divide everything by 10. So we get x minus 4 is greater than 5. Now we're going to create our two cases. X minus 4 is less than or equal to, or less than negative 5. So here's my two cases. We're going to add 4. So we have x is less than negative 1 and x is greater than 9. So greater than 9, less than negative 1, interval notation being negative infinity all the way up to negative 1, or a positive 9 all the way on to infinity. All right, good job. All right, now y'all are ready to jump in and take a look at your homework. Don't get tricked by fraction problems like this one. Just remember the rule, you multiply by the reciprocal, okay, to clear that fraction. So don't get mixed up on problems like this. It's just like the one we did just a minute ago, except we're going to use the reciprocal to clear that fraction.